All right, CAC, here we are. We got some learning to do about triple, quadruple, and multiple slit openings. And you hopefully have done that already in terms of single and double slits, and you have a good sense of that. So if you haven't done that, you might want to go back and look at those videos before looking at the multiple slit pattern idea that we're going to look at today. So let's get started. So just to remind you, we had single and double slit earlier, and what we were looking at is how single slit would create one big opening and surprisingly a little bit of interference pattern. And then actually back in topic 4, we had looked at double slit and the pattern we get there. And then most recently, we were starting to look at if there was a envelope with single and double slit. But today what we want to do is back up and take off the envelope and just look at the double slit again for a moment. And you notice we had this fringe pattern that we, when we ignore the single slit envelope, has these regular bright spots that happen at certain intervals. And I showed that to you in class. And one of the things that if we're not having this single slit drop off here, that must be because this opening B must be much smaller than D. So this particular picture would definitely show some single slit. But if these openings were tiny, then we wouldn't see much drop off, which is what we're going to be looking at the end of this video. In any case, what happens if we add a third opening? So we add a third opening, some cool stuff happens. So we have 3 openings now. And so we're still ignoring the envelope. And we see we get this secondary constructive interference patterns here, which we never had before. We didn't have that on the double slit. We suddenly get it on the triple slit. We get one of these little guys here. We also notice that the bright spots that we had are more distinct. They're supposed to be in exactly the same places, no matter how many fringes we have. So I might have moved those images a little bit off. But the idea is that we don't have a change in spacing, but we do have a change in location maximums. In other words, at this constructive point, it's going to be brighter and it's going to be more localized. Okay, and that's because these other very, very dim things are starting to form. And when we look at, say, here we have 4 openings, we see that we have 2 bumps, and you can see how these bright spots here are just really bright, and that there's this long area of destructive interference before the next one. And so the fringes aren't sort of merging into each other anymore. They're sort of distinct, bright fringes. If I go all the way to 5, we really see that there's this big gap here. And these, look at these secondary maximums. Now there's 3 of them. So when there was 4, there was 2. When there was 3, there was 1. When there was 2, there was none. So the pattern is actually quite nice. It turns out that the number of these secondary maximum is always 2 less than the number of openings. So here we have 5 openings and we have 3 secondary maximums. The main maximums, meanwhile, are getting brighter and more localized. Okay, and this would continue if we just kept adding more and more slits. You'd keep having n-2 little secondary maximums here, and these bright spots would get more and more distinctly localized, which would be cool. Meanwhile, we were ignoring the single slit envelope, which was actually going to be there. So if the openings were as this is, where you're showing a big enough opening in terms of how B, right, is smaller than D, but it's not horribly smaller, so that we will see this envelope, we'll see this, the 5 pattern occurring. See how there's n-2, so there's 3 secondary bumps here, 1, 2, 3 little bumps there, and that's happening within this. It's interesting to note that the location of these major maximums here are in exactly the same place, no matter if you have 5 or 4 or 3 or 2 of these openings here, but you have to have at least 2. So that's what happens in terms of these secondary maximums and the locations being the same, but where the locations are, the light is much more localized all in one place, not spread out over a blurry fringe, but instead nice, bright, distinct spots. The other thing that's happening is as you add more openings, you're going to be adding more energy. So here we can see that it's getting brighter as it goes up. As you have more and more openings, you're getting more and more brightness as you go up. And notice the secondary, right? There's 3 for 5 slits, 2 for 4. This is not showing the rest of them, but they would be there in the continuations. Let's look at the energies and what happens here. So if you had a single slit, you would have a certain amount of intensity, a certain amount coming through. And when you go to 2 slits instead, the intensity of this peak right there, just at the peak, ends up being 4 times more than the intensity of 1 opening if the openings are all exactly the same size and the laser's hitting all of the openings. That's because the amplitude is doubled. You had 2 openings, so the possible amplitude has doubled at the constructive interference location, at those places where the constructive interference is happening, right here. That's the constructive interference part. You're adding 2 amplitudes so that the intensity, which is related to the amplitude squared, is 4 times bigger. So when you have 3 slits, you have 9 times more intensity because the amplitude is 3 times bigger. Here the amplitude is 4 times bigger, so the intensity is 16 times bigger in comparison to the original one. So that's pretty cool, and something that is often asked of you is to understand, well, why does it get brighter? Not only do they localize, you can see how they're not spread out. This is all spread out. This is really localized, but they're also brighter as you move on. So that's pretty cool. Here's how IB would show a graph of one. This is with, let's see, we've got 1, 2. We've only got 2 secondary minimums. So this would be for 4 openings. And we can see that I, compared to I0 being when there was 1 opening, which is what it says here, that we should be 16 times the intensity. You can see 5, 10, 15. So on the graph, the peak there is at 16, which is pretty nice to see. What happens if instead of 5, we just keep adding more and more and more and more and more till we have like thousands of openings? What happens is these secondary minimums just disappear. They're so tiny and unimportant, can't really see them. And these bright spots get so localized that they just look like individual laser beams. And it's almost like you have a bunch of different laser beam spots and a big gap of destructive interference between them. So I wanted to show a quick little video related to that of us trying to show that. Let's see if this works.
All right, so looking at a DVD, and we've seen how in a DVD it has all these cool colors that you get. That's because a DVD acts like a diffraction grating because it has all these tiny little bumps on the surface where the information is stored that acts just like a diffraction grating. A diffraction grating is like multiple slit diffraction with almost thousands and thousands of them. If we look at this particular one, well, wait a minute. Here, let's say hi, Nan. Hi, that's my wife, and she's helping me out here. That's my dad's painting, which is in the background. And we're looking at this diffraction grating. And the diffraction grating is got 600 lines per millimeter down to 100 lines per millimeter. And what's happening is there's tiny little openings on this plastic here that act like a multiple slit opening. We saw how with 2 slits, it was kind of blurry fringes. Look at when we go through, say, 100, how the fringes that we get are very distinct. And we have bright spots followed by dark spots. And then the bright spots are all sort of by themselves with this long area of destructive interference and very distinct points. Let's go ahead and go to the 600 all the way over. And we can see how far away those points are. So when we go from that 600 lines per millimeter, what we're seeing is that the spacings on the laser grid, on the diffraction grating, are really close to each other. So as we expect, the fringes would be further away. And if we go back to the 300 or the 100, where the gaps on the diffraction grating, right, are farther apart, then we get closer fringes here as we expect. The other cool thing is if we put different colors through, the spacing on that would be different on the wall. So that's a diffraction grating. Thanks, Dan.
Okay, so finish this thing up. So when you have a diffraction grating, and I'll just clarify, 600 lines per millimeter means there's more lines, so the gaps between them is going to be even smaller, which would create D being tiny. And if D is tiny, then the fringes on the wall are going to be farther apart, as you saw back in topic 4. The equations we use for these, for any of these, In order to get this distance here, which would be S, we still use d sine theta equals n lambda, as we've done in the past. So diffraction gratings, there's no new math here. It's just a conceptual idea that we're working for. What's next is going to be if we shine different colors at the same time through a diffraction grating. And that's going to be cool because when we shine, say, white light through diffraction grating, the spacing that you get for these bright spots, it's going to separate, and that's going to allow us to use a diffraction grating to separate colors. But that's the next video, so we'll wait on that. Hopefully, you have a good sense of where we went with multiple slits as we go from 2 on up to thousands of openings, and the different things that will occur when we do that. So thanks a lot, and I hope that helped. I would like to say that a lot of this I couldn't have done without this site on hyperphysics, and they really helped us out. They do things a little differently. I've tried to edit things to be more IB-ish. For example, here they're showing the intensities relative to 2 slits instead of what IB likes to do relative to 1 slit. So you'll see some differences there if you're looking at hyperphysics, but it's a great site and you can learn a lot from them. So I encourage you to do that. Next on, try the DDD, Dilemma del Dia, for multiple slits, and see you soon.